In this example, we're going to look at the slope and y-intercept of a linear equation in the context of a model. We'll use the slope-intercept form to determine both the slope and y-intercept of the given equation, and then we'll look at their units to talk about what each of those mean in context. So this problem tells us that a truck is hauling a large plastic water tank. The total weight of the tank changes depending on how much water is inside it. We'll let X be the number of gallons of water in the tank. The total weight of the tank, which we'll call Y, and is measured in pounds, can be modeled by Y equals 8.3454x plus 67. You'll note that that coefficient on X is not a very nice number, but it's actually determined by the weight of a gallon of water. So, the slope of this equation, let's look at that. So we have this Y equals 8.3454x plus 67, and thinking about Y equals mx plus b, we can simply look at that equation and state the slope. So the slope is the coefficient on x when the equation is written in slope-intercept form, and so in this case it's going to be 8.3454. So we'll write down that the slope is 8.3454. Now, thinking about what that means, every time x, think about what we know about rates of change. Every time x increases by 1 unit, y is going to increase by 8.3454 units. We'll note that that slope is positive, so as x is increasing, y is also going to increase. And I'll just jot this down in my notes. Every time x increases by 1 unit, y increases by 8.3454 units. Now, I haven't included these units yet. I'm not quite ready to talk about the context of the model until I've got this increase part down. So every time x increases by 1 unit, y increases by 8.3454 units. So thinking about what that means in context, the units on x are gallons of water, and the units on y are pounds. So thinking about this slope in context, this means that for each additional gallon of water, the total weight of the tank will increase by 8.3454 pounds. And so I'll write that down. And I'll make sure that I get those units of pounds in there. I'm going to abbreviate them with LBS. Okay, now the next thing we're going to do is state the y-intercept of this equation. And so we know that the value of b tells us that y-intercept. So looking at that, in this case b is 67, so we'll state that the y-intercept is the point 067. And so in the context of this model, we're thinking then when x is 0, to get to the context, this will just be our setup. So when x is 0, y is 67. And so in context, that means that when there are 0 gallons of water in the tank, the total weight of the tank is 67 pounds. And so that's telling us the weight of the tank, in this case, without any water in it. I'll summarize that then. In context, if there are 0 gallons of water in the tank, the total weight is 67 pounds.